today we discuss the characteristics of alternator, or it is alternative known as synchronous generator. So first the word synchronous generator, that comes from the synchronous speed at which the rotor of the alternator is rotating, which is driven through a steam turbine or hydraulic power turbine, or it is a coupler or Francis turbine driven if it will be hydraulic power plant. So synchronous speed, from this the number of cycles per second, that is known as the frequency of AC supply. P is equal to number of poles, and the relationship between F is equal to 120. F is equal to Pn by 120, where Ns is the synchronous speed, P is equal to number of poles. So how it is derived, I will just explain. That means from this figure, it is a small cylindrical rotor that is used in steam turbine, or that is also called turbo alternator. That is turbo or smooth cylindrical type rotor, that is called turbo alternator. Whereas in this figure, that is called silent mode rotor, that is invariably used in hydroelectric power plant based turbine. So here is, for example, it is the four poles, they are arranged from north pole to south pole, again north pole and south pole. So in this figure, first figure, from north pole to south pole, in half revolution, that constitute one half cycle. And again, from south pole to north pole, it constitutes another half cycle. So if this turbo alternator rotates for one revolution, then it will constitute one cycle. So that is that case for pair of poles. I have taken pair of poles means one north pole and one south pole. Whereas if we take P is the total number of poles, then number of pairs of poles will be just simply P by 2. So again, if there will be P by 2 pair of poles, then the number of cycles per revolution will be simply P by 2. And we have the RPM, the revolution per minute of the rotor, or that is Ns by 60. I simply put in place of Ns. That means the relationship volts between this F and 120F by, or N is equal to 120F by P. So number of cycles per revolution into number of revolutions per second, that is simply number of cycles per second. And finally we get F is equal to Ns by 120. So this is all about the synchronous speed. So in actual power plant where alternative driven by specific speed, that means the Ns, the speed of the rotor, whether it is steam driven, that is 1500 rpm or 3000 rpm. In case of hydro power driven, that is 150 rpm to maximum 600 rpm. Then accordingly, as per Indian standard frequency, we have 50 cycles per seconds. Then this will be the P into ns by 120 or 120 into 50 divided by P, that is equal to ns. So, as our source either steam or hydroelectric power, our source is potential energy of water and the steam energy. So we can increase the steam energy as high as, so that we can get output, that is 1500 rpm or 3000 rpm. Whereas in case of hydraulic power plant, the speed is limited to the potential energy per head of this dam. So that is limited to 300 to 600 rpm in India. Hence, that depends on ns. So accordingly, we fix the number of poles, that is 6000 by ns. So if we for steam driven turbine, then that will be 6000 by 3000 rpm. So P is equal to 2. In case hydroelectric driven turbine, then that is 150 rpm. So it is 40 numbers. In Bulla powerhouse, the discharge speed through which the piston this strikes the turbine, that is the coupled turbine, then the speed is limited to 150 rpm. So to get the 50 hertz supply, we must accommodate 30 number of volts to get the Indian standard frequency 50. Understand my point? So from that point, there is a limitation or the difference in size of hydraulic power plant alternator and stream giving power alternator comes into picture. That means we have in case of 4 poles, from north pole to south pole, that's another 1/2 cycle. That's also 1/2 cycle. Here is also another half cycle, another half cycle. So in case of 4 pole, that is for one revolution, it completes 2 cycles per cycle. Simply understand it. The type of alternators. That is, one is turbo alternator. Turbo means that is high speed. That the meaning is high speed. That means in India we have 50 hertz cycles per second. So the revolution per minute will be 3000. In case of America, where 60 hertz frequency is employed, their speed will be 3600 rpm. For 2-pole type alternator. If we choose 4-pole type cylindrical alternator, then the speed will be 1800 rpm or 3600 rpm. So in India, we have 1500 rpm or 3000 rpm speed is employed. So generally we employ 2-pole type. So the speed is naturally 3000 rpm. So there is a basic concept, the kVA output of alternator, whether we choose 100 kV or alternately the output power of alternator, where the power factor is range is operated fixed, then you can say that is 100 megawatt or 500 megawatt or 800 megawatt, depending upon the type of super thermal power plants where these high capacity or high megawatt alternators are installed. So the KVA output, that is invariably directly proportional to the volume and speed of the rotor. Volume of the rotor and speed. Volume means that is the pi by 4 d square. That is the area and that is the length. So that comes to volume, and ns is the synchronous speed. The diameter of the rotor, L length of rotor, ns synchronous speed. So for steam driven turbine, we can raise the speed, or we can burn the coal to produce superheated steam as high as or greater than 535 degree temperature based superheated steam, so that we can acquire the desired speed. That means if we choose 300 RPM with two pole construction, then the volume will be depends upon the d square into L. So for a large steam power plant, the rotor is driven. If we put the diameter length high, there will be very high centrifugal force. Very high centrifugal force. So there will be a problem in mechanical paralysis. So in this case, we have to limit the size of the diameter, and generally the diameter is assumed to be around 1 meter in length, the diameter. And the length is to be large in axial length and small in diameter. But whereas in case of hydroelectric or salient voltage turbine, salient voltage rotor, for example, Bulla powerhouse, hydroelectric powerhouse. So that speed is limited to 150 RPM. To maintain the frequency 50 Hz, we have to make the number of poles is equal to 40. Constant number from ns is equal to 120 f by t. F is 50 Hz, ns that is 150 RT. We can't increase beyond that because water head is limited. So we have to increase the number of poles 30. So we have to indirectly increase the diameter to accommodate 30 number of poles. The size of the rotor will be very, very large. So in case it is circular cell, we can accommodate 40 number of poles. That's why the diameter of salient pole type alternator must be very, very large, and it will gradually reduce if the speed will increase. If it is 300 RPM, then it will be 20 number of poles. So that's why the diameter of silent pole type alternator must be large. Here the large diameter. And since the volume, the length is to be reduced. Diameter increases, so length will be reduced. So that comes small in axial length. Then where this turbine in motion, because of this centrifugal forces, there will be high centrifugal forces if we run the turbo alternators at high speed to increase the diameter. That's why the centrifugal, to limit the centrifugal force, the axis of turbo alternator is mounted horizontal. Whereas in case of hydroelectric power giving, the axis is vertical. Okay? Then the last point, that is the difference. The cooling is a big problem, a big hurdle while designing the type of alternator, basically in case of turbo alternators. So above 100 megawatt hydrogen cooling is a must to limit the temperature rise. We adopt hydrogen cooling or turbo alternators. Whereas in case of silent voltage or hydroelectric alternator, natural air cooling will be sufficient. Natural air cooling will be sufficient, and in cost comparison, the cost of turbo alternator will be more as compared to the silent voltage alternator. So that is the basic difference between silent voltage and turbo.